Hello, welcome back to this video series on program synthesis using SMT solvers. Today I'm going to talk about an interesting problem. I want to make the connection between integer addition, integer subtraction against bitwise operators. Okay, so what I mean by connection is this. I want to be able to say what is the meaning of say x plus 1 in terms of bitwise operators like or, bitwise and not, and so on. And the same with subtraction. Okay, what is the meaning of x minus 1 in terms of subtraction? I would like to make this connection explicit. Okay, so how do we do that? Of course, we will now use the program synthesizer for this purpose. Okay, so let me show you my program synthesizer, and we will discuss the outcome. So first is the increment by 1, right? As you can see, the grammar is very simple. I am only allowing XOR and bitwise OR and minus. This is a BV neg means minus X, for example. A BV not means bitwise not. So I'm only allowed to use these, but not the plus and minus, right? So I'm asking the synthesizer to synthesize a program for me, which takes an input X and comes up with an output which is also bit vector 8. The reason I picked bit vector 8 is just to speed up the process. Usually I use small numbers so that I can manually generalize it for all possible bit sizes. Okay, so what is the specification? In this case, you have two options, right? Either to give specification or train it by examples. I decided to go by specification route. It's much easier. Given an X, the program must just add a 1 to it. So it's extremely simple. So this is the constraint. Of course, the output of the increment function better match the specification, right? That's basically it. So let's see what kind of synthesis it comes out for us. Okay, and then we will discuss the connection. Okay, so very quickly we learned the connection between increment and bitwise operator. So here is the synthesis function, right, which takes an input X as a well, X is the input, and it shows us the output, which I will write it for you in regular language. We do bitwise not, which means tilde. Usually tilde is the bitwise not, and then we put a minus in the front. So this is basically it, which means that we should be able to implement increment by 1 using just these two bitwise operators. Okay, and that means we can also generalize it, right? We could say in theory x plus y can be computed just using these two. Okay, because we keep adding by 1 until we counted y times. Okay, so we are able to make a connection between arithmetic operation and bitwise operation very easily. Okay, so now the next thing we are going to do is to make a connection between decrement and bitwise operators. Okay, let's do that. So what I'm going to do is I will just show you the program very quickly, and then we talk about it. So the decrement operation is basically going to implement the same structure more or less. So the only difference is highlighted for you. So it's the same as the increment, except that we are subtracting by 1. Other than that, the grammar remains the same. So let's see what kind of program we can synthesize very quickly. So let's see. Very quickly, we synthesize the output. And as you can see, there is no difference whatsoever other than these two operators got flipped, okay, or are exchanged. So again, I will write it for you. What it means is that the decrement function basically is nothing but taking an x and giving us x minus 1, right, which is minus x, and then we put a bitwise not operator, which is the tilde. So this is nothing but x minus 1, and this is nothing but x plus 1 here. Okay, so as you can see, we can actually do arithmetic operations like plus and minus just using bitwise not and the bitwise. This is not a bitwise negation, but this is just negation, right? You put a minus in the front. Okay, so we have bitwise not and bitwise negation is good enough for us to implement increment and decrement operations. Okay, that's basically what I wanted to show you. Thank you for your attention.